Hey, what's going on, guys? In this video we are going to take a look at binary addition. Now let's look at the basic addition. In binary, the maximum value we can have is 1. For example, like whatever the base we have, if it's decimal, the base is 10, so the maximum number we can have is 1 less than the base, that is 9, because it starts from 0 to 9, already 10 numbers. And if it's octal, the maximum number is octal base is 8, so the maximum number we can have is up to 7, because starting from 0 to 7, it's already 8 numbers. Like that, binary, the base is 2, so the maximum number we can have is 0 to 1. Okay, now let's look at the binary addition. So we can add 0 and 0. If you add 0 and 0, this is going to be just 0. And if you add 0 and 1, it's going to be 1. And if you add 1 and 0, you will get 1. And if you add 1 and 1, here you will get 2. But in binary, there's no 2. Like in decimal, when you have 9 and the next number will be 0 and we will have a carry 1. For example, 9 plus 1, 0, and we will have a carry 1, and that will be here. That's 10, right? Same as that, for binary, the maximum number is 2, so we cannot have 2. So we will have a 0 and a carry 1, and that will be here 1 0. So if the first number will be 0, and then we will have a carry 1. It's basically 1 0. If you add 1 and 1, it's 1 0. Now the next thing is, let's look at a decimal number. In decimal, for example, if you add 294 and 568, we will have 8 plus 4, let's say 563, 4 plus 3, 7, and we have 9 plus 6, 5, and we have a carry 1. Like that, when we add 1 1 1 in binary, we have 1 1, so we will get 0 and 1 carry and 1, so we will have 1 right here and we will have carry 1. Okay, and let's look at some binary and decimal. So 6 plus 7, we know that is equal to 13. Now let's do the same thing with binary. In binary it will go like this: 1 2 4 8. When we have 4 digits, it will go like this. The place will be go like this. So if you put 0 1 1 0, you can see in this place we have 0, in the second one we have 1, and in the third one we have a 1, and in the fourth one we have a 0. So 4 plus 2, we have a 6 right here. Instead of 6, we can write it in binary like this. This is decimal to binary conversion. And for 7, we had to have a 4, and we had to have a 2, and we had to have a 1, and this would be 0. So this is going to be just 0 1 1 1. Now let's see whether when we add these two numbers, whether we get 13 in binary. 0 plus 1 1, 1 plus 1, we will have a 0 and a carry. 1 plus 1, we have 0, and this carry will go right here, so this 1, and we will have another 1 right here, so 1 1 0 1, 1 1 0 1. 8 plus 4 12, 12 plus 1 13. Okay, so we have a 13. You can see this one matching to this one. Now let's see a full adder. Full adder. Let's look at the input: an, bn, and then cn minus 1. This is previous carry, and this is cn, and sn is sum. Now let's go ahead and add them. an, bn, and cn, sn. This is cn minus 1, and this is cn. Okay, now here you can see like an and bn are input to the full adder. Cn minus 1 is carry from the previous one, and this is cn is carry, and the sn is sum. So let's look at the possibility: 0 0 0 0 0 1, 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 1. Let's put 1 1 1 right here. Let's create a table, continuous. AN, BN, CN minus 1, SN, and then CN. Okay. Now here you can see if we add 0 0 0, that's going to be just 0. We don't have a carry, so carry is also 0. If we add 0 0 1, this is going to be 1, and we don't have a carry, so that's 0 0 1 0. If we add, we will have a sum 1 and the carry is 0. If we add 1 and 1, we will get sum 0 and a carry 1. And if we add 1 0 0, we will have sum 1 and carry 0. 1 0 1, we will have sum 0 and a carry 1. And 1 1 0, we will have sum 0 and a carry 1. And here, if we add 1 1 1, we will have sum 1 and a carry 1. Okay, and that's it. That's it for the full adder. Okay, now let's look at a binary addition. Let's look at another number. Let's say we have 0 0 1 1 0 1 0 1 1 1 0 1. Here you can see, let's convert this one into decimal. We know that the first value is always, it goes like this. 1, let's use a different color. It's 1 2 4 8 16 32 64. It goes like that. Now first one we have a 1, and we have an third one is 4, so 1 plus 4 5, and fourth one is 8. 4 plus 8, actually 1 plus 4 5, 5 plus 8 13. So this number is 13 in decimal. And here we have 1, and in the third place we have 1, so it means 4. 1 plus 4, and in the fourth place we have another 1, that is 8, and in the fifth place we have another 1, that is 16 plus 16. 16 plus 8 24, 24 plus 4 28, 28 plus 1 29. Now let's see, when we add these two binary numbers, whether we get the same answer as this. If we add this one, 9 plus 3 2, and we have a carry 1. 1 plus 2 is 3, 3 plus this carry, that's 4. So we have to get the 42 from adding these two numbers as well. 1 plus 1 0, and we have a carry 1. Let's use a different color. 0, and we have a carry 1. 1 0 0, we have 1, and 1 plus 1 we have 0 and a carry 1. 1 plus 1 0, and this one will go right here, and we have a carry 1. 1 plus 1 is 0, and here we have a carry 1. Okay, now you can see in the first place we have a 0, second place we have 1, that is 2, and in the third place we have a 0, in the fourth place we have 1, that is 8, and in the fifth place we have 0, that is 16, and the sixth place we have 32. 32 plus 8 is 40. 40 plus 2 42. This is 42. Okay, and that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn DLD1 or computer architecture 1, there are a bunch of videos in my playlist. I hope you guys watch it too. Don't forget to subscribe. See you next time.